NASA, HPD, space weather, citizen science programs, contributions to the HamSCI workshop.
Thank you. I would like to thank. Okay, I would like to thank Nathaniel for the opportunity to give this presentation in the HamSCI workshop. I am Esayas Shume, I'm a program scientist in NASA headquarters in the heliophysics division. So a lot of people contribute. I'm just basically my name. Okay, how about now? Okay, you just see my name, but there are a lot of people in here, both the space weather program and the citizen science working group, to contribute to this presentation. Okay, so let me see. Is this? Oh, it's not going anywhere. Yeah. I don't see it in the screen. So you said you do this, right? But it doesn't work. I just couldn't move it.
You just use the arrow keys? Oh, that doesn't
matter.
Yeah, just use this.
Ah, okay, thank you. Thank you. All right, okay. So, yeah, mostly my interest is using the high end of the frequency, the radio spectrum for ionosphere diagnostics like UHF, VHF radar. But this also interests me, and as a program scientist in NASA headquarters would be really interested in development and using for leveraging scientific research. So basically the outline of my presentation is, first of all, I will give you an overview of what our division is like, and also the space weather program, the citizen science program, and also how we, going forward, how would support, sorry about that, how would support the HamSCI community, you know, for research and innovation. Yeah, so first of all, let me just say what our division is about. Our division is in the SMD, that's in the Science Mission Directorate, one of the divisions. And basically, it has a large scope of studying the entire heliosphere from the sun interior to the Earth's upper atmosphere, through all the interplanetary sphere and until the end of the heliosphere. That's what we are studying. So basically, there are two main things our division is doing. One is we have missions at important locations, strategic locations, to be able to study and investigate processes, phenomena in the solar system. The other thing is, as you know, are ROSES programs. I think most of you are familiar with the ROSES program. They include, some of them are PI-led, some of them are led by teams. And then we solicit the modeling, data analysis programs. The other ones are technology development programs, like suborbital balloons, CubeSat investigations. And also, maybe you don't know, but we also solicit programs like experimental laboratory experiments, plasma experiments. So in a nutshell, this is basically, we do ROSES and mission, okay? So that's what we do. You know, if you just want to expand a little bit, the objective is, maybe we don't have time to go through all this, but I will just summarize for using the blue dots. The heliophysics division, our strategic objective is to understand the sun, its interaction with the Earth and the solar system, and most importantly, space weather, which is really affecting a lot of our life these days. Okay, I think most of you are familiar with this chart. You know, this is our fleet system of the heliophysics division, which is called the Helio system observatory. You might see this chart is filling up every time you see, and the missions are color-coded right here. Some of them are in formulations with yellow in implementation. Some of them are in the primary operations, and some of them are in extended operations. So those are color-coded, you know. Like, for example, the Helio Swarm and the Solar Cruiser are newly added recently from the MIDEX program. And also we support CubeSat programs. Like all of those CubeSat programs are, some of them are in development, some are already in orbit. All this is just to give you an overview of, you know, what our division is doing. We do mission, and the missions are in strategic location, so that we're able to understand the solar system, the sun, and the heliosphere. And also we do ROSES programs, research, technology, development. Okay. With that, I go to the Space Weather program, which I am affiliated with. Is basically this was it has its own vision and mission. The vision of our Space Weather program is to advance the science of space weather to empower a technological society, safely thriving on Earth and expanding into space. So basically, as my group, and also the heliophysics division as a research arm of all this, you know, groups of organizations, you know, put together by the Swift law. Our group is a research arm. What does that mean? We are working such that, you know, researchers get the support they need, so that we have enough maturity in the research and before it moved to operations. Okay. What I am saying is, right now the space weather models don't work very well. You know, recently you might have heard about the Starlink satellite. You know, the loss of those satellites. You know, so all models got it wrong because there was no, you know, good research results to put into operations, you know. So we have to do a lot of, our group do a lot of investment in doing research so that we have a mature research to be translated into to operations. Some of the activities we do, one of the major program we do is the R2O to R research, which is research to operation to research. There is research and we give it to operations. So they tested it, and if it doesn't work, they give us back, and then it kind of loops until it gets maturity. So I think Nathaniel has some kind of support in this program. And then we also have the SBIR program, Small Businesses Initiative Research, where you know, small businesses could propose innovative ideas, and in different phases they got supported, they get evaluated, and so that they develop their technology. And then I think it was late last year we have the Space Weather program have selected 4 CubeSat. Most of them, 2 of them, I think 2 of them, let me see. The first one, the Cube XX and the Sense8 are solar, whereas the Diangalo and WinCube are ionospheric. The Dinaglo, I think Dinaglo studies the lower atmosphere coupling to the upper atmosphere, whereas the WinCube studies magnetosphere, ionosphere coupling research. So these are some of the activities we are doing, and also the ROSES program, just to give you a summary of what has been supported in the ROSES program since 2017, with all this scientific teams, we've been doing supporting the research. And for ROSES 2021, the subject matters are high latitude radiation exposure and downstream updating of solar wind and the CME forecast. These are the subject matters for ROSES 2022 in the R2O2R program. What else? Okay, yeah, there is also other things we do. Our program has got a suite of instruments called Hermes, which will be deployed on a gateway, and I will be discussing later. I mean, these are some of the things which are coming shortly. The other program we are doing, the Center of Excellence. Center of Excellence, group of scientists form a center where they come up with big ideas of a big space weather issue idea, which will help space weather research, advanced space weather research, and and help transition to operations. Okay, so these are some of the upcoming, and then I think the Center of Excellence program was released for public for comment. I think some of you might have seen it. People are giving comments on this, and until April, it's open until April 1, and will be basically soliciting research proposals for 2022. Okay, what else? Yeah, that's very important. The CEO, Center of Excellence, solicits this highly ambitious research, and this group of people with many varied experience try to solve some big space weather problem. That is Gateway. The reason I brought Gateway is a platform, a lunar platform on the which will be on lunar orbit. Basically, this will help the Artemis project and also manned mission to Mars. So this is an article. I think Frank also showed this earlier. But most importantly, the reason I brought this is our division will have a suite of instruments called Hermes on Gateway. So what is Hermes? So this is a different art of Gateway. So Hermes, first of all, let me get the acronym here. Hermes is Heliophysics, Environmental and Radiation Measurement Experiment Suite. That's what Hermes is. So already an instrument is under development. Where do you find Hermes? On Gateway will be placed right there. And basically, as I said, the Heliophysics division is in charge of the Hermes. These are among the few instruments which will be on Gateway. And there is also a European equivalent. IRSA is ESA, that's European Space Agency Radiation Sensor Array, will be also joining Hermes. Those are basically Hermes will concentrate on understanding the cause of space weather variability as driven by the sun and modulated by the magnetosphere. How is it possible? Because it's in the lunar orbit. Lunar orbit just comes in the magnetosphere and go out also on the solar wind. So it has, let me graphically show what this is about. Yeah, this is what, this is the lunar orbit. So Hermes and Gateway could go to the magnetosphere and go right to the day side. So by doing that, it helps to study the solar wind and also the, so how the sun is modulated by the space weather is modulated by the sun and the magnetosphere. Okay, yes? Oh, okay. Oh, in that case, I go. Further, this is, I think, citizen science program. I'm going to skip this. So these are the programs of the citizen science projects. The Aurora, the HamSCI, I don't have to tell you about that, and Sun Grazer and the Solar Jet Hunter, and also these are the other citizen science projects which helps and solar eclipse processes and Sprite, heliophysics Odified. This is the one I just showed to you, Nathaniel, Odified, yeah. And then there is also the High Desert Partnership Academic Excellent. I think I have to go here. So what do we basically, we have interest, you know, in, and how can the space weather program helps? Basically, it helps. It helps that you use your citizen science data, the radio data, the you know, the received, and you know, you receive data for scientific. You know, how can you convert that into something useful for scientific research, space weather research? You have large networks, 3 networks of, you know, transmitter, receiver links. So, and how do you use that? Those kind of research are encouraged, for example. What else? And I would like to talk about I have to talk about this heliophysics big year. We call it in the heliophysics division the heliophysics big year, or HPY. The upcoming 2 solar eclipse, one is I think the annular, which is on October 14, and then total solar eclipse on April 18, and on the upcoming solar maximum. All this combined, we call them the big heliophysics years. And we are investing a lot of, there is a lot of interest to collaborate with people in the citizen science committee, including the HamSCI, and also Frank Bauer, he was mentioning about that ISS, yeah, the RESS. So those are the things which would interest us. And what else? Also, if the HamSCI community, for example, if you want to leverage, we have the space assets, both, you know, Explorer inside the magnetosphere, the ionosphere, and if you want to like leverage that data for research, those can be like available if you kind of approach the right way. What else? Yeah, that is all I have. So I rushed it. I'm sorry about that. I would be happy to take a question, or I can, during the banquet, we could talk and you can ask me more questions if you are interested.